Hello everyone. Today we are going to talk about TCP Handshake. So if you're already familiar with the TCP, you might be knowing that this is a connection-oriented protocol, and we have a protocol called UDP, which is a connection-less protocol. It doesn't require any handshake or involved or any connection to be established first. So as the name suggests, connection-oriented. So TCP first make sure that your particular machine is connected to a server whom you're communicating to. So how does it work? Let's see. So how does it work in practically? So TCP handshake basically involves some packets exchanged in between client and server. So let's take an example. This is a PC1, or we can say this is a client. Okay, and this machine is trying to communicate to a server. Let's say this is the server machine. So the server is, let's say, it is trying to communicate to 8.8.8. Okay, and you have one private IP, let's say 192.168.1.3. Okay, this is your private internet, your local IP basically, and you're trying to communicate to the server on top of TCP. You're trying to make connection to TCP. So so how does it work basically? First, this client machine has to establish a connection with server. So there are some packet exchange happen. So the packet exchange generally looks like this. So it's like client and server. So we have this. Let's say we have this client and server, and initially what will happen is like client will send a SYN packet. So first packet in the TCP handshake is a SYN. SYN is a synchronized. It's a full form is a synchronize. So what it actually sends in SYN, we will just now talk about. So after the SYN, the server has to respond with the like SYN-ACK. Okay, and then eventually the client will send the ACK acknowledging. So SYN is the first packet, it's a synchronize, and then the server has to respond with SYN and ACK, and then finally the client will send the acknowledgement, and after that, whatever the application the application protocol they are using. So TCP is a like transport layer protocol, right? So whatever the application, like let's say they are using HTTPS. Okay, is it using HTTPS? Then it also uses TCP, right? So TCP, so the lower protocol will be TCP. So what will happen after this? Client can eventually send the GET request. Basically, it's a, GET is on like HTTPS. Okay, so this will happen after that, and first it has to create a connection for every communication which is using TCP protocol. Like let's say HTTPS is there, and then we have FTP. It also uses TCP as a like transport layer protocol, and they all have to make the connection first by following this three-way handshake. This is also called as a three-way handshake. Okay, so they all have to follow this basically three packets exchanged, and then only they can process with their application, whichever application protocol they are using, and they can process with that flow. So let's see what does SYN basically do internally. So first, when we send a SYN packet, so what client has to do, it has to create a ISN. ISN is a initial sequence number. So this is just a random number. You can say it has to create one number, and then it has to follow that number in throughout the packet exchanged. Okay, so this number will be basically, let's say it's a 10,000. It sends a 10,000 number to the basically server. So what the server in also has to do in the response? So let's say this is a client to server, and then server to client, if it also has to send one SYN-ACK. So what is SYN-ACK basically? SYN-ACK is a two packets. We can say the two packet are being sent in a single packet. Two packet information. So first, the SYN which was generated by client. Let's say this is a 10,000 number, and it was sent to the server, and now SYN. Which is also coming from server. The server also has to generate one ISN, initial sequence number. Okay, so server, let's say, picks up let's say 20,000. So now server will send the 20,000 in sequence number and acknowledgement. What is acknowledgement? Basically, the acknowledgement is coming from for this SYN basically. So server is acknowledging that it has received this SYN, and now it is acknowledging sending acknowledgement for this SYN. So what it will send that now as an acknowledgement number. It expecting, because it has received 10,000 sequence number. This is also called a sequence number along with the initial sequence number. It's a field in TCP which is being set with the sequence number. So now it will say that server will say that I am expecting 10,001 in next packet, and now it has sent that 20,000. Okay, so this is how flow works. And when the finally the client will send to the server with the acknowledgement, it will say that it will acknowledge for this 20,000. It will say that I have received 20,000 and now I'm expecting 20,001 in the next packet response. So now whatever the communication which will work on HTTPS, and that is on top of TCP itself. So in the TCP fields, you will see that the sequence number and an acknowledgements work on these numbers increments also. Okay, so the reason being that if the client sends a 10,000 sequence number packet and the server is acknowledging and incrementing that number by one, and now it is telling to the basically client that it has already received 10,000, now it is expecting 10,001. Now when this packet will go right in this sequence in this acknowledgement, so 20,001 will be incremented. Along with that, the sequence number for TCP will be 10,001, which will tell the server that it has received the next packet. So it is basically forming a chain by incrementing these numbers, so that the server will know that these are all interrelated packets. Okay, so this is the main flow of TCP handshake. So I can just show the packets here as well. So let me just pack capture something here. I might have to generate a traffic to some website. Okay, we can just stop it here and then let's see. So let's see only TCP packets. Yeah, here you can see the SYN and SYN-ACK, right? So 443 is a HTTPS protocol number, which runs on a like for HTTPS we generally use 443. Basically, it's a port number, so we generally use for destination as a 443. Now you can see there are three packet exchange, right? SYN, and ACK. This is the three flow which generally works. In the SYN packet, if I we go to the SYN, so this is the TCP header. So in the TCP header, if you see there will be one flags. These are the flags field. So this is 1 byte number, and in this yeah, in this 1 byte basically we set these flags. So these are the one bits being set in this 1 byte, and then the SYN is this one. If this is set, then it means like this is SYN packet. And yeah, so this is a relative sequence number which is being sent. As I explained, is the sequence number. This is a sequence number. It's a random number generated by the basically my machine from my browser when I entered the google.com. So this was a number generated by my machine. And now, yeah, if you see here the sequence number which came from the machine, it's a 34726. When I send acknowledgement, when the SYN-ACK came, basically it is saying that acknowledgement number is this 727. 726 was the first sequence number generated. So the acknowledgement number which was returned, it was a 727, which is acknowledging that it has already received 726, and it increments it by one. And it also sends its own sequence number which I mentioned. It's also called initial sequence number, because as per like protocol theory, it's an initial sequence number, but it's being set in the header itself. Okay, so 139 is being sent by the server, and if you go to the final which is acknowledgement from the client, you can see here the acknowledgement number would be 140, which was the increment of the 139, which came from the server. So it's like basically there are two numbers, like sequence number and acknowledgement number. So this is how it works. So all other fields we'll see in detail in further videos, but for now I wanted to explain how sequence number works and how it forms a chain after that. Okay, so basically this number which is talking about, so this is pair basically. So this is all basically sequence number and acknowledgement number. This is a grouping of both. So it acknowledges for the previous packet, which is a 10,000, and sends the acknowledgement number, and its own sequence number being sent in the from the server side. Okay, and when it sends this acknowledgement, final acknowledgement, so this group will be called as a acknowledgement number, and then the new sequence number would be increment of this 10,000, and it will be sent here, right? So this is how it works, the complete flow of the TCP handshake. Thank you all. Thanks for watching. We'll see more things in detail in further videos. Thank you.